This is an ATR 72-600 full flight simulator, a multi-million-dollar device designed to replicate the real aircraft to the tiniest detail. And this is what the primary flight display looks like when you fly an RNP approach. How do you do it? This is what I will talk about in this video. Hello aviators, how are you today? My name is Magnar Nordahl and I'm an ATR instructor. In this video, we will look at instrument flight procedures used for departure, arrival and approach in ATR aircraft with glass cockpit. RNP is a type of area navigation, RNAV, that includes onboard performance monitoring and alerting to ensure the aircraft remains within the required navigation performance, RNP. Specifically, we will look at the standard instrument departure, SID, standard arrival route, STAR, and RNP approach with LNAV and VNAV. Fasten your seatbelt and let's take off. The video was recorded in an ATR 72-600 full flight simulator. The simulator features a 6-axis motion system, an exact replica of the aircraft cockpit, a 200-degree infinity vision system, and an instructor station with one great addition, a tablet displaying the captain's primary flight display, PFD. Without it, instructors would rely on X-ray vision. The screen recording was made during a typewriting course involving 2 first officers. During training, they alternate between flying from the right-hand seat and acting as pilot monitoring from the captain's seat. I recorded the tablet with a camera standing on the table, which limited filming to moments when the simulator's motion system was not operating. In other words, this was during the early stages of training, before the simulator starts enthusiastically throwing people around. That said, the trainees perform very well, and by the time you see this video, they have already passed the skill test. For those of you not yet fluent in ATR hieroglyphics, here's a quick tour. The cockpit is dominated by 5 screens, 2 primary flight displays, PFD, and 2 multifunction displays, MFD, in the front of each pilot, and an engine warning display, EWD. If you want a more detailed introduction, you can watch this video. In this video, we will focus on the primary flight display and the associated control panels. Right in the middle sits the artificial horizon, also known as the attitude direction indicator. This is basically the instrument that prevents pilots from accidentally turning the aircraft upside down. On the left side, we have the airspeed indicator. On the right side is the altimeter, and the outermost scale is the vertical speed indicator. The space above the ADI is dedicated to Flight Mode Annunciator, FMA. This is where the aircraft politely informs the pilots what the automation is actually doing, which is always nice to know. The lower section is the navigation area. It shows the aircraft heading, along with the navigation source selected by the pilot. And right in the middle of the compass rows sits the course deviation indicator, CDI, quietly reassuring us that we're actually flying in the direction we intended to go. We'll come back to the intricate details when they become relevant for the flight. There are 2 control panels. First, the Flight Guidance Control Panel, FGCP, where the pilot selects the appropriate navigation source and flight director modes. And yes, before anyone asks, this little button right here is for the autopilot. Finally, this is the Index Control Panel, ICP, where we can select automatic or manual target speed. In this video, we will depart from runway 34 at Napier Airport in New Zealand. We will fly to Auckland. The departure route is OBLOX for Quebec with BOSA transition, which is entered into the FMS. This departure is a straightforward procedure. However, we must pass BOSA at or below 10,000 feet. The transition altitude is 13,000 feet. The first officer is pilot flying. This arrow means the flight director will follow the navigation source selected here, FMS number 2. The captain has selected FMS number 1. On the navigation area, we can see the name of the first waypoint and the bearing and distance to the waypoint. We are lined up on the runway and the CDI is centered. The magenta color means the information is provided by the FMS. We are cleared flight level 180 or 18,000 feet, which is set with the altitude selector knob. The weight of the aircraft is 20,800 kilos and the FMS has calculated the takeoff speeds as follows. V1 108, VR 108 and V2 111. V1 is shown here. V2 plus 5, 160 knots, is shown here after auto speed has been selected by pressing the auto man button. Increasing V2 improves climb performance in case of an engine failure, at the cost of a slightly longer takeoff distance. Before departure, the first officer selects heading, navigation, which arms lateral navigation mode, LNAV, indicated airspeed, and vertical navigation, VNAV, which arms VNAV IS mode. LNAV and VNAV will activate when we are airborne. The green flight director bars will provide guidance once the aircraft is airborne. Vehicular takeoff. The captain increases power. Airspeed alive. We can now see V1, VR and V2. V1 rotate. Positive climb, gear up. LNAV and VNAV IS are active. The pilot will maneuver to keep the little box in the intersection between the flight director bars. The autopilot is selected on. Lazy pilot. Passing acceleration altitude, climb power is set and the target speed increases to 170 knots. This is controlled by the FMS. The white F indicates flap speed, where we can retract the flaps. When passing 1100 feet on the radial altimeter, the maximum bank angle in turns is increased from 15 to 27 degrees. The FMS has also armed the VNAV alt mode, which ensures the aircraft will level off at 10,000 feet before reaching BOSA waypoint. Without LNAV, the pilots must select 10,000 feet themselves. On this flight, I told the trainees to select manual target speed and flight Whiteberg plus 10 knots. This is the speed for the best rate of climb. The vertical speed indicator, VSI, shows the rate of climb in hundreds of feet per minute. We are passing OBLOX and the aircraft turns towards BOSA. The heading bug is centered by pressing the heading button. I tell the trainees to select normal climb speed and I press the auto manual button to activate automatic target speed. The standard climb speed is 170 knots. I didn't record the aircraft leveling off at 10,000 feet, so I will show a video from another flight. Here, the aircraft must pass a waypoint at or below 5,000 feet, which is shown here. We use VNAV IS for climb, and VNAV Alt is armed. VNAV Alt is armed automatically when the FMS calculates we will reach 5,000 feet before the waypoint. VNAV Alt STAR. VNAV Alt Green. There is also a speed constraint of 170 knots until the next waypoint, so the pilot must reduce power to comply. Passing the waypoint, the aircraft starts to climb again in VNAV IS mode, and the pilot increases power. A new altitude constraint shows up. Thanks to the FMS and VNAV mode, the workload of the crew is reduced, improving situation awareness. Back to the flight from Napier to Auckland. We are now passing transition altitude and set standard altimeter reference. The aircraft continues climbing to flight level 180. We are cruising towards the first waypoint of the standard arrival route inbound Auckland. It's called DODQ1 Alpha and takes you from DODQ waypoint to MRAG, where the approach procedure commences. The flight crew will conduct the approach briefing. This will be an RNP approach to runway 23 left, flown with LNAV and VNAV. Minima is 340 feet, or 317 feet above the runway. When we are inside 5 minutes from the top of descent, the vertical deviation indicator appears on the ADI. The magenta box, often called a brick by the pilots, provides vertical guidance all the way to the missed approach point. The flight is clear descent to 7,000 feet, which is set. When you select VNAV PATH mode is activated and the altitude select is armed, ensuring the aircraft will level off at 7,000 feet. The target speed is increased to calculated cruise speed at 7,000 feet, in this case 240 knots. This is standard speed for descent. The crew will perform the descent checklist. If the speed exceeds 247 knots, the autopilot will pitch the nose of the aircraft up, preventing overspeed. In this case, the pilot reduced the power in time to avoid it. Passing transition level, flight level 150, and the crew sets the barometric altimeter reference to reported QNH, 1017 hectopascal. They can now perform the approach checklist. We are now in Takeoff waypoint and cleared 5,000 feet. We must cross the waypoint at 5,000 feet or above with maximum 220 knots. After takeoff, we are cleared 3,000 feet. We must cross MRAG at or about 3,000 feet. The FMS calculates we will cross the waypoint at 3,461 feet. Max speed is 210 knots. We have cleared RNP approach on a 2-3 left and press the approach button. This arms vertical flight path mode, VFP. We must also set the altitude for final approach fix, 1670 feet, which means we select 1700 feet. The target speed is now 170 knots, which is the limit at Oreso waypoint. It is also the speed we will start configuring the aircraft for landing. The two lines at 185 knots marks the maximum speed for extending the flaps to 50 degrees. Flaps 15. Target speed 140 knots. Radio altimeter alive. Maximum speed for landing gear extension is 170 knots. VFP green. Set guard on altitude. Maximum speed for flaps 30 is 150 knots. With flaps 30, the reference speed is the approach speed, 106 knots. before landing checklist. This approach is called a 3D approach because the autopilot can follow both lateral and vertical guidance. When passing 1000 feet on the radio altimeter, the maximum bank angle in turn is restricted to 15 degrees. This is indicated with those green lines and a low label on the FMA. Those two lines mark our minima.
500.
The brown area is the ground. 100 feet above,
Approaching minimums.
minima.
Minimums.
Autopilot off. It can remain engaged until 160 feet.
$200.
Yaw damper off. It must be disengaged before landing.
$100.
When passing the last waypoint on the flight plan, the flight director modes
50,
are cancelled.
40, 30, 20, 10.
And touchdown. And that is all for this time. In the next video, we will have a look at other types of approaches, including ILS, localizer, and VOR DME. As usual, a big thank you goes to the members of this channel. They make this content possible. Thank you for watching, have a wonderful day, and happy landing!